This is the first of 3 short lectures about materials and production. As you will see, there is quite some interaction between these two. Also, a third entity, the shape or design, is highly dependent on the type of material and on the selection of the right production process. To start with, what is a material? Although everybody understands what is meant with the material, it is very hard to give a nice and clear definition. Words like matter or substance pop up, although these words are not 100% spot on. So often we need to describe the word material. A material has properties, and these properties are independent of its size and shape. So a material has many mechanical, physical and chemical properties. For example, a material has density, it has strength, it has electrical resistance. We can determine such properties by taking samples. But in the end, material properties are independent of the shape and size of the sample we analyze. Before, I have discussed the concept of structures. Think about the truss structures you have seen, the beam elements, and the stiffened shell structures. All these structures are made of materials, and some of the properties of these structures are directly or indirectly related to material properties. So we might ask, how are structures made of materials? I will use the following sequence. First, materials are retrieved from ores, which are obtained from the crust of the earth by mining. Or materials are retrieved from, for example, oil by diffraction and processing. Once the material is made, the materials will be shaped into semi-finished parts. Think, for example, about metal sheet, which is rolled to thickness on a mill. These semi-finished products, or half fabricates, can be further processed into structural elements like beams. A metal sheet, for example, can be cut and formed into a C-frame. Once we have structural elements, joining these elements together gives us a structure. Today there are many materials. Structural materials can be classified into 4 main groups: metals, polymers, ceramics and composites. Each of these categories have a huge diversity. Metals, for example, have many different groups like steel, copper alloys, etc. And each group has many different variants. There are thousands of different aluminium alloys and grades. Similar diversity is there for other materials, like the polymers or plastics, and the composites. If we look at the basic properties of these 4 main material categories, only metals and composites are used in aerospace applications. However, one ingredient in composites is a polymer. But as pure material, a polymer does not have sufficient mechanical properties to use it in high-performance structures. Ceramics, on the other hand, are strong and stiff enough, but they don't have any flexibility and deformability. Think about pottery. If you drop a vase, the vase will break in many pieces without noticeable deformations. It is brittle. If a metal component is hit and fails, at least it will dent before it fails. So metal alloys and composites are the main materials used in aeronautical applications. They are used because they have sufficient mechanical properties, high strength, high stiffness, and they are not brittle. In the next lecture, we will look at the material properties in more detail.